From the tiniest particles to the vastest galaxies, everything we see, touch, and feel might be nothing more than the vibrations of invisible strings. What if the true nature of reality isn't made of solid little dots, but of something far more elegant and strange? For thousands of years, humanity has been searching for the ultimate story of the universe. We told myths, built religions, and eventually created science. But none of our ideas have been as bold, as beautiful, or as controversial as the one that promises to tie all of physics together into a single, perfect framework: string theory. Throughout history, we humans have always tried to look deeper. We once believed the world was made of just 4 elements: earth, water, fire, and air. Then we discovered atoms, tiny building blocks of matter. Later, we found that even atoms were made of smaller things: protons, neutrons, and electrons. But the deeper we looked, the weirder reality became. When scientists tried to understand the behavior of these fundamental particles, they ran into a wall. The act of observing them changes them. It's like trying to measure the exact temperature of a cup of soup by plunging a massive thermometer into it. The very tools we use interfere with what we're trying to see. So physicists made a radical assumption. They decided to treat these particles as perfect mathematical points with no size at all. Surprisingly, this crazy idea worked incredibly well. This point-particle approach led to the creation of the Standard Model of particle physics, the most accurate and successful theory in the history of science. Thanks to it, we built modern computers, smartphones, medical imaging machines, and nuclear power. Almost everything in our technological world rests on this foundation. But there was always one enormous problem lurking in the shadows: gravity. While the other 3 fundamental forces are carried by particles, gravity, according to Einstein, is the curvature of space-time itself. When physicists tried to combine gravity with quantum mechanics, the equations didn't just fail, they exploded into meaningless infinities. The mathematics broke down completely. It seemed impossible to describe all of nature with one consistent set of rules. Then came one of the most elegant ideas in the history of physics. What if the problem wasn't that particles were too big, but that we were imagining them in the wrong way? What if, instead of being zero-dimensional points, the fundamental ingredients of the universe were tiny, one-dimensional strings? Imagine incredibly small, vibrating strings, so small that they make quarks and electrons look enormous by comparison. Different ways of vibrating would produce different particles. One vibration pattern creates an electron, another creates a quark, yet another creates the long-sought graviton, the hypothetical particle that carries the force of gravity. Suddenly, all the forces of nature emerge from the same fundamental object: vibrating strings. String theory didn't just try to fix gravity, it promised something far greater: a theory of everything, a single elegant framework that could explain every single phenomenon in the universe. But as beautiful as this idea sounds, it comes with heavy costs. String theory requires the universe to have not 4 dimensions, but 10. We only experience 3 dimensions of space and 1 of time. The other 6 dimensions, according to the theory, are curled up into tiny, invisible shapes so small that we could never detect them directly. Even more troubling, after decades of work, no one has been able to make a single clear, testable prediction that could be verified in a laboratory. Some of the brightest physicists in the world have criticized it harshly, calling it not even wrong, or beautiful mathematics that may have nothing to do with physical reality. Is string theory the ultimate description of nature? Or have we fallen in love with a mathematical fantasy that's simply too elegant to abandon? And yet, Even if string theory turns out to be wrong about the true nature of reality, and it has already proven incredibly valuable, it has become a powerful mathematical toolbox that helps physicists tackle some of the hardest problems in science: the mysteries of black holes, the information paradox, the earliest moments after the Big Bang, and the strange behavior of quantum gravity. Sometimes, building a perfect paper boat helps you understand the principles that allow you to construct a real ship. The ideas born from string theory are teaching us profound lessons even if the final picture looks different. It reminds us that pushing the boundaries of human imagination is never a waste of time. In the end, we still don't know what reality is truly made of. Maybe we never will. But the search itself reveals something deeply human and inspiring: our relentless curiosity, our refusal to accept easy answers, and our willingness to dream up the most extraordinary explanations for the cosmos we inhabit. String theory may be right, it may be wrong, but it has already shown us one undeniable truth. The universe is far stranger, far more mysterious, and far more beautiful than our everyday intuition could ever imagine. So, what do you think? Are we living in a universe made of tiny vibrating strings? Or is this just the latest chapter in humanity's long story of trying to understand the incomprehensible? Leave your thoughts in the comments below. If you enjoyed this journey into the frontiers of physics, make sure to subscribe and hit the notification bell so you never miss an episode. In the next video, we'll dive even deeper into one of the strangest predictions of modern physics. Thank you for watching, and thank you for daring to ask the biggest questions.